out from one piece of one side of an equation. So we just took angle 2 and swapped it out for angle 4. And we also had the transitive property. So again, I'll give you an example for the meaning. So let's say that we have that angle A is congruent to angle B. And let's say that angle B is congruent to angle C. So it's the transitive property that lets us say that angle A is congruent to angle C. Because the transitive property is when you're replacing an entire side of an equation. So we took out all the right side of that first equation and replaced it with what it was congruent to, which is angle C. Also, just as a little bit of a side note, I want to just real quick make sure you guys know the difference between like measures of angles and the actual angles. So notice here that we have that the measures of angles and that they're add up to be equal to each other, because measures of angles are numbers, and so numbers are always equal. Versus down here, we just have like a regular like angle A, angle B, and we can say that they're congruent. And that's because just regular angles are like shapes, and shapes are congruent, because congruency talks about shapes. So angle measures are numbers and are equal. Angles are shapes and are congruent. So that's just like a little notation thing there. All right. Okay, so those are the two that we talked about last time. And I'm also going to add one more that we're going to need for our first proof. We're going to be using vertical angles. And technically, it's the vertical angle theorem. Ran out of room. I abbreviate theorem, THM. Vertical angles theorem. And you guys already know that vertical angles are congruent. That's what the theorem says. Vertical angles are congruent. All right, so with these three things, we have enough to do our first proof. So if you guys will look at your white packet that you picked up, we will look at the first one. All right, so here we are given that angle 3 is congruent to angle 5. So I always mark that in my picture. So I'm going to show that angle 3 is congruent to angle 5. And we want to prove that angle 2 is congruent to angle 1. So I'm just going to kind of circle those, it's going to help me kind of visualize what we're trying to get to. So we're trying to prove angle 2 is congruent to angle 1. All right, so by the way, did it say anything about lines A and B being parallel? No, right? Okay, so in proofs, we don't want to assume anything. So even though lines A and B might look parallel, we're not going to assume they are parallel, which means we can't use any of the corresponding, alternate interior, same side stuff that we used when we were solving, because those only work when you have parallel lines. So we're going to be stuck with using vertical angles. So before we write anything down, just take a second and talk to your group about why do you think it seems reasonable that angle 2 is congruent to angle 1? Ready, go.
Yeah, well, you can do that because you said you can know if they're parallel.
All right, okay, so let's start talking about it together.
And 3 and 1 are congruent. So 1 and 2 would be congruent. No matter that. Yeah, for opposite, that means they're proven to be.
All right, so first step, we're just going to write down our given stuff. So just write down that angle 3 is congruent to angle 5, and it's given in a little T-chart. Okay, and I heard some of you guys making connections. Does anyone want to share a connection that they made with like one of the angles? Yeah.
Angles 3 and 1 are vertical angles.
Sure, 3 and 1 are vertical angles. That's true. Let's add that to our proof because it might come in handy later. So step 2, let's say angle 3 is congruent to angle 1 by vertical angles. And actually, what sticks out to me is that, see how angle 3 is in both equations?
Yes.
So let's do a transitive step and combine those two equations to say that angle 5 is congruent to angle 1 by the transitive property. Did you have a question or thought? All right, let's see. I'm also looking at my proof and thinking, we haven't mentioned angle 2 yet. Does angle 2 have a special relationship with anything?
2 and 5 are vertical.
Sure, yeah, 2 and 5. Okay, so angle 2 is congruent to angle 5 by vertical angles. And I'm noticing again, look, there's angle 5 in both equations. So let's do a transitive step and combine those equations. So in step 5, let's say angle 2 is congruent to angle 1 by the transitive property. And there you have it. That's what we're trying to prove. So we're done. All right. Okay, you guys try number 2. Okay, let's go ahead and talk about it. So after your given step, can someone share what you did next? Yeah, go for it.
I said angle 5 and angle 3 are vertical angles.
Yeah, okay, that's great. So angle 5 and 3 are vertical angles. So they are congruent. If you weren't sure if you could do that or not, something that might have helped you is looking at your proof and thinking, oh, angle 3 needs to be in my final step, but it's not in my proof yet. So you're kind of looking for, does angle 3 have a relationship with anything? And it did. Okay, what do you guys do next? Anybody? Transitive property, amazing, yeah, because angle 5 is part of both equations. So I can switch out an angle 5 with an angle 3. So angle 4 is congruent to angle 3 by the transitive property. And there we go, we're done. Okay, so now we are going to do the same thing but add one more step. So over to your proofs toolkit and we're going to add something else to it. We're going to talk about the definition of congruent. So the definition of congruent says, if angle 1 is congruent to angle 2, then, so I'm going to draw an arrow, the measure of angle 1 equals the measure of angle 2. And we can also use this definition to go backwards and start with the measure of angle 1 equals angle 2, and then get out of that, angle 1 is congruent to angle 2. So I'm going to make this arrow double-sided to show that you can go forwards or backwards. You can start with congruent and go to equal, or you can start with equal and go to congruent. Either way.
Oh wait, so you said we're not like finishing the whole packet today?
Right, totally. We're gonna skip around. All right, so back over to your packet. So tell your group, what is different about number 3 than what we've done so far? What do you notice? Ready, go.
More numbers.
All right, can someone share one thing you noticed about what's different? Yeah.
So it's asking you to prove the measure of the angles and not just like if they're congruent.
Totally, right? Yeah, we're asking, are the measures equal and not just the congruent step? And that's when our definition of congruent is going to come in handy. All right, so I want you guys to try and at least get to the step where you say angle 1 is congruent to angle 8, and then we can do the last step together. Okay, so work with your group and at least try to show that angle 1 is congruent to angle 8.
You're out. I caught it.
Okay, I bet you guys did something with vertical angles. What stuck out to me is that angle 6 is congruent to angle 8 by vertical angles. And then I said that means that angle 1 is congruent to angle 8 by the transitive property.
Okay. Do we need to like put the like 1, 2, 3?
Oh, like the steps? You don't have, yeah, no, you don't have to put the numbers there. Yeah, that's okay. I think it just helps me stay organized. So how do we go from congruent to equal? With the definition of congruent. So we just say the measure of angle 1 equals the measure of angle 8 by the definition of congruent. So that's what I'm going to put in our blanks down there. So I'm going to say we use the definition of congruent to switch back and forth from congruent and equal. All right, so you've done your first 3 proofs. Okay, so everybody stand up. Stand up, stand up. Okay, gotta shake it out. Okay, give everybody at your table a fist bump and say you're doing great, and then you can sit back down.
You're doing great. You're doing great. Can I go use the restroom?
Mm-hmm. Okay, guys, let's look at number 5. Let's get some parallel lines in there so we can use our other stuff. Oh, we'll skip 4. You can do 4 for practice at home if you want. Oh, actually, before we do number 5, let's add some more stuff to your toolkit. Because now that we have parallel lines coming into play, we can use things like alternate interior angles and corresponding angles and all that kind of stuff. So first, we're just going to look at all the congruent ones, and then we'll look at the supplementary ones later. Okay, so in this box, I'm going to add 3 things. I'm going to say alternate, exterior, comma, alternate interior, and corresponding angles theorem. So these were the 3 theorems that we get congruency from when we have parallel lines. So for the meaning, I'm just going to say when lines are parallel, these angles are congruent. All right, awesome, awesome. Let's go back to your proof. Number 5. So I'm going to use a highlighter to highlight on parallel lines. So if you have a highlighter, maybe you want to get yours out too. I think it's always helpful to highlight things. So I'm highlighting that A is parallel to B. And then I'm just going to mark up that angle 1 is congruent to angle 2. Uh-huh.
Where does it say like it's parallel?
Oh, right here. So yeah, this symbol means parallel. Yep, good question. All right, so before we start writing, it's just always a good idea to pause and think and say, okay, why does it seem reasonable that angle 3 would be congruent to angle 1? So I want you guys to talk to your group and see what kind of connections you can come up with. Ready, go.
They are corresponding.
All right, let's start with our T-chart and just write down our givens. So A is parallel to B. Angle 1 is congruent to angle 2 because it's given. All right, and once I write down my givens, the next thing I do is I think, okay, in my proof, I need angle 1 to be congruent to angle 3. But I haven't even mentioned angle 3 yet. It's not showing up in my T-chart. So I look at angle 3 and I say, okay, is angle 3 having a relationship with any of the other angles I've already talked about? So does angle 3 have a connection to angle 2 or angle 1?
Yes.
2, why? Yeah, because they're alternate exterior angles. So on step 2, I'm going to say angle 2 is congruent to angle 3 because they're alternate exterior angles. And I abbreviate alternate ALT and I do exterior EXT because otherwise it's so much writing. So you can do that too if you want to. So alternate exterior angles. All right, and then it's always a good idea to step back, look at your equations, see if they have anything in common. Do they have anything in common? They sure do. What shows up in both of our congruency statements?
Angle 2.
Angle 2. So since angle 2 is in both equations, that means we can do a transitive step and swap it out. So in step 3, I'm going to say angle 1 is congruent to angle 3 by the transitive property. And that's what we wanted to prove, that angle 3 is congruent to angle 1. Yes?
In the first step, you have to write like A is parallel to B.
Yes, because that's part of your given information. Okay, other questions? Questions? Can you guys show me on a scale of 1 to 5 how you're doing so far? How are you feeling? Totally don't expect 5s because it's so brand new. Okay, all right. Let's see. Okay, let's look at number 7. So on number 7, I want you guys to try it with your group first, or on your own, and then try this with group later, and then we'll go over it together. So it's going to be similar to the one that we just did.
The corresponding.
All right, let's talk about a few things on number 7. So first of all, I heard from a couple of groups saying that 7 and 10 are corresponding, but they're not. Because do we know that A and B are parallel?
Yes.
No, only M and N are parallel. So notice 7 and 10 are on the lines A and B and on the transversal N. So we can't say 7 and 10 are congruent because they're not on parallel lines. Okay, so what else can we do then?
5 and 10 are alternate exteriors.
Sure they are, because they're on parallel lines M and N. So those are alternate exterior angles. So in step 2, we can say angle 5 is congruent to angle 10 because of alternate exterior angles. If you weren't sure how to get there, if you're ever stuck, remember, look at your proof and pick an angle that you haven't talked about yet and look for relationships. So like I'm looking at angle 10 and thinking, okay, does angle 10 have a relationship with anything I've already talked about? And we found, yes, it has a relationship with angle 5. So that's how we got step 2. All right, and then I'm noticing 5 is in both equations, angle 5, so I can do a transitive step to swap them out and say angle 7 is congruent to angle 10 by the transitive property. And then last but not least, how do we switch from saying things are congruent to saying that measures are equal? Definition of congruent, yeah. So we can say the measure of angle 7 equals the measure of angle 10 by the definition of congruent. Okay, awesome. After this one, we're going to do one more, and then we will take a break, and I'm going to teach you a new game. So get out of your seats in a little bit. Okay, let's do number 8.
Yes, ma'am.
All right, so this time we have M and N are parallel and A and B are parallel, so that's super helpful. So I'm going to highlight on my pairs of parallel lines. And I'm just going to circle what we want to prove, because that's going to kind of help me visualize things. So I'm going to circle 7 and 10 because we want to prove that they're congruent. Okay, so before you write anything down, remember, take a step back and look at it and think to yourself, why would that be reasonable that 7 and 10 are congruent? How can I make connections? What do I notice? And guess what? There's a ton of different ways you could solve this proof. Okay, so we'll talk about one, and then we'll just I'll show you some other ways. So there's not just one right way to solve most proofs. There's lots. Because for me, I was looking at it and thinking, okay, well, I wasn't given any angles to start with in my given, so I'm just going to pick angle 7 from my proof and find an angle that's congruent to angle 7. So what jumps out at you guys? What's an angle that's congruent to angle 7?
8.
2.
Okay, I heard 2, I heard 8,
3.
I heard 3.
8.
Let's go 3. Remember, any of them can get you to the end of the proof, but let's just go for 3. Okay, so angle 7 is congruent to angle 3. Why? Because they're corresponding. Okay, now remember, you're going to look back up at your proof and think, okay, angle 10 needs to be included in my T-chart. Is angle 10 having a connection with any of the other angles I've already talked about, 7 or 3?
3.
3. What are 10 and 3?
Alternate exterior.
Yeah, angle 10 and 3 are alternate exterior. So next we can say angle 3 is congruent to angle 10 because they are alternate exterior angles. All right, and now we're just going to do a transitive step since angle 3 shows up in both equations. We can say angle 7 is congruent to angle 10 by the transitive property. And remember, there's lots of ways you could have done this proof. So if you're ever looking at a proof like at my key online and you're like, mine's different than yours, but I'm pretty sure mine's still right, just come ask me and I can check it for you because you totally probably have another right way of doing it. So like for example, on this one, we could have said, hey, 7 is corresponding with 15, and then 15 and 10 are alternate exterior. That would have worked. Let's see what else would have worked. We could have said We could have said 7 is alternate exterior with 2, and then 2 and 10 are corresponding. That would have worked, right? And we could keep going. There's tons of ways we could have connected those, all right? So there's more than one way to solve a proof. Okay,